Okay, so the last part of 7.8 is a few applications. Okay, so for the application problems, we're going to use words like at least, more than, greater than, no more than, at most, less than. And so you have to know the symbols for these. So if you think about if I say at least, I want at least a 90 in the class. I want at least $100 for something. At least means the lowest amount that I want, the smallest amount. And so when we want at least, like if I say at least $100, okay, that means I want to get greater than $100. And so at least is the greater than or equal to, okay, and I could or equal to 100. So I want $100 or more is what at least means. And so we use greater than or equal to anytime it says at least. If we want more than or greater than, that one's easier. It's just the symbol. More than or greater than is just greater than symbol. Okay. No more than and at most, again, is a little bit harder. So if I say at most 10, right, or no more than 10, what I want is 10 or less. Okay, that's what it means. I want the most I can have is 10, so I want 10 or less. And so this symbol is less than or equal to. Okay, and same at most is the same thing, less than or equal to. And then less than is just less than. Okay, so those are our keywords for inequalities. Okay, so for the applications, again, we're gonna have a word problem. We're gonna write the inequality and then we're gonna solve it. So a charity will raffle off a new car donated by a car dealer. Raffle tickets will be sold for $50 each. How many tickets must be sold to raise at least 20,000? Okay, so we want the number of tickets. So X is the number of tickets. And so the raffle tickets will sold $50 each. So to get the total cost of tickets of all the tickets, we would take $50 and multiply it by X. Then 50 for each ticket by how many tickets would give me the profit. Okay. And then we want it to raise at least 20,000. So how we're going to write that is we want 50x. Okay, so again, at least is greater than or equal to. We want it to be greater than or equal to. The lowest we want it to be is 20,000. And so this would be the inequality. And then we solve it. So we have 50x is greater than or equal to 20,000. To solve this, we divide by 50 on both sides. And again, we don't flip it unless we divide by a negative. So since I'm dividing by a positive, I'm not flipping the sign. Okay, and so I get x is greater than or equal to 400. So what does that mean? I need to sell at least 400 tickets. Okay, so I can sell 400 or more tickets, and that will give me this profit. So that's one application of an inequality. Okay, so another one, a math student has grades of 85, 98, 93, and 90 on all 4 tests. If he must average a 90 or better to receive an A for the exam, what scores can he receive on the final exam and earn an A? And we're assuming that the final exam accounts the same as the other exam. Okay, so we're talking about finding an average. And when we find an average, we add up all the scores and then we divide by how many we have. Okay, so we're gonna let X be our score on the final. And so again, we're going to add up all the scores we would have. We have these 4 tests and we would have the final exam. So we have 85 plus 98 plus 93 plus 90 plus X, that's my 5th exam. We would divide it by 5 because I have 1, 2, 3, 4, 5 tests. And he must average a 90 or better. So we want this score, which is his average, to be greater than or equal to 90. Okay, and then we have to solve this. So first thing, again, we combine our like terms. So I'm going to add 85 plus 98 plus 93 plus 90. I would just do, again, that all at the same time on your calculator. So I get 366 plus X over 5. Again, it's greater than or equal to 90. Okay, and I know my calculator is a little bit different than yours, but what I would just do is, again, most of your calculators can handle just adding all of those up. At the same time and getting, again, 366. Okay, so then we have 366 plus X and then divided by 5. So remember, we have to get rid of this division by 5 because they're both being divided by 5. So I can't subtract the 366 because it's being divided by 5. So I want to multiply both sides by 5 to get rid of the division. And then I get 366 plus X is greater than or equal to 90 times 5 is 450. And then we're going to subtract our 366. And we have X is greater than or equal to 84. Okay, and so I need to earn an 84 or higher to get an A. Okay, and then the last one. A car salesman makes $1,000 each week that he works and makes approximately $250 commission for each car he sells. If a car salesman wants to make at least $3,500 in 1 week, how many cars does he need to sell? Okay, so the first thing is always, okay, what are we trying to find? So we're trying to find how many cars. So that's my X. Okay, so then we want to write a scenario. So he makes 1,000 each week and he makes $250 commission for each car he sells. He wants to make at least 3,500 in 1 week. Okay, so we know it's $250 per car for each car. So it'd be 250 times X, the number of cars, plus he still gets 1,000 each week. Okay, and we're just talking about a week. So he gets that plus 1,000. And he wants to make at least 3,500. So again, at least means that it's greater than or equal to 3,500 because the lowest he wants to make is 3,500. And then again, we're going to solve this. So we subtract 1,000. We get 250x is greater than or equal to 2,500. And then we're going to divide both sides by 250. If you do that, you get x is greater than 10. And so he needs to sell 10 or more, or at least 10 cars. Okay, and so those are the applications. So we will practice with this next class. And then whatever questions you have, please come and bring them to class.